Okay, so what is energy? As Yana said, the ability to do work or cause change. There we go. What are the different forms of energy? Yes, so if you have to catch up, we'll do a quick review on this.
Kinetic.
All right, so we got kinetic. What else?
Physical.
How so?
I don't know.
When you say physical, meaning what?
Moving, like.
Okay, which is the kinetic. What else? Everybody charged their phones last night?
Potential?
There we
That's
go,
what I was
potential. And what, use one example as what? What's an example of potential energy? If you charged your phone, what did you do?
You hold in a battery.
Isn't that the rubber band thing?
It can be as well.
The stretching.
Elastic.
Stored energy, okay? So we'll go through a couple here. All right, energy has a number of different forms.
Can we copy that?
Yep. All of which measure an ability of an object to do work or change another
You
object.
wrote that down yesterday.
Yes, if you had it yesterday, you don't have to rewrite it.
I don't have that.
So, if the bottom point makes more sense to you, you can go with that. There are different ways that an object can possess energy. So what does that mean?
There's different ways for objects to produce energy. To have energy, can do the energy.
We talked about the rubber band, right? If I take a rubber band and I stretch it out here, does it have energy?
I guess elastic.
What happens if I let it go? What happens to the rubber band?
It gets back to size.
Turns into kinetic.
If I let it go really quick, what happens?
It'll snap.
It snaps back. If I pull it one side and I let go, what happens?
It'll smack against your hand.
Or if I shoot it,
It'll fly.
it flies. Okay? What about the sun? Sun doesn't snap back, does it?
No, but it's on fire.
Okay, but it's this giant ball of burning gases, right?
Yeah.
And how do we feel that energy?
And heat.
Sun.
Well, it is the sun, but how?
And heat.
The hotness, degrees.
The rays.
The rays, okay? And that's some of the other energy forms that we'll see here.
Wait, I'm afraid.
Different forms.
Yeah.
Kinetic and potential, those are mechanical energies.
Do we write that?
down yesterday.
Yeah. So, if you have a water wheel that's spinning on a stream, if you go to these old mills, and it's water, the stream is pushing this big wheel around, it's turning a shaft that's either...
That's kinetic and potential.
Well, those are two types. But kinetic is energy in motion. If it's kinetic, it's moving. If it's potential, it's waiting to do something. So a 9-volt battery is waiting to do what?
Use it. Be
used. Okay? If it's sitting here, if this is a 9-volt battery, it's just sitting here.
Alright, I got a question.
Is it kinetic energy or is it potential energy?
It's potential energy.
Yep. If I take the battery and I put it into a machine, okay, and the machine moves, is that movement kinetic energy or potential energy?
Potential energy.
The moving machine,
Kinetic.
kinetic.
I mean, yeah, that's not
When you hear movement, moves, does something, it's usually always kinetic.
Okay, so I got a
What's
question.
your question?
Well, if people have a battery and they say it's getting done, and they put it in a freezer, is that true?
I know you could charge batteries in the freezer.
People say if you put them in the freezer, they'll last longer. Usually they'll freeze. Put them in the refrigerator, they'll last longer. But I'm going to pose this question to you. If you take your house batteries and you put them in the freezer or the refrigerator,
House batteries?
like regular, your batteries you use in
That's
your
what I'm
house,
talking about, yeah.
Yeah, batteries.
they supposedly stay charged longer. But in the wintertime, when it's 10 degrees outside and you turn the key on your car, why does that battery die then?
Because it's cold. It needs to be warmed up.
So why doesn't the battery in the refrigerator not die?
Because it's
Okay, where am I can go?
I was gonna say stored.
Because a car battery has
Oh,
more
you can use it.
energy
I just
stored
wanted to know where it was.
than
So why would
yeah, you get stored in a
The battery needs to be warm.
Okay, so the battery needs to be warmed. Because what's in a car battery versus your batteries used in your electronic devices?
Heat?
You're the car guy. Are batteries in your car dry batteries or are they wet cell batteries?
What?
They're wet cell batteries. They're filled with sulfuric acid. Okay, the major component in the sulfuric acid solution is water. So what happens to it? Mr. Bauman could probably go into this
It
even more
freezes.
detail.
Basically, it won't start up unless it's
Defrost.
warmed up.
Right, so we have frozen battery acid in your car, right? And it doesn't crank. That's probably part of it if it does freeze, right? Now, your home batteries aren't filled. You don't fill them up when they empty out. You don't fill them with acid. You guys will be burning your fingers off. All right, they're dry cell batteries. Dry cell batteries are working on a couple, there's a little moisture in those batteries, okay? There's like a paste that they use in a line when they make the batteries. And remember we talked about the positives and the negatives that go on?
Yeah.
That's what happens in your battery. Same with the solar cell. The solar cell is basically a flat version of a battery. Then we just connect a wire to it to charge a bigger battery for later use. Okay? That's why we can't take the plug for a lamp or a radio and just hold it up at the sun and hoping that the radio is going to go on. You're like, well, it's solar energy, right?
How come you can put a potato, yeah, charge your iPhone in a potato?
Because a potato has a very large amount of potassium. That element, okay, has a lot of these, okay? A lot of positive charge, so it has a lot of hydrogen. And what happens is it gives off all these ions. We get lots of this stuff, so we're giving off these hydrogen ions, some of our energy. So then we get left over negatives. Right? If we take more positives, you're left over with what? With the negatives. And then you have this, you have a whole bunch of positives and negatives. What does that look like? If I do this, what did I make?
A battery?
A battery, okay? That's all it really is. Okay, you can do it on lemons too, but lemons don't work as well as a potato does, okay? So, thermal or heat energy. So you guys talk about the sun. We get warm from the sun, right? How about you go down into the earth and you trap that steam pressure from those geysers and underwater hot water pockets?
I don't understand why they have that.
Because it's relatively free. Once you design the setup, it's there all the time. Ryan, what you got?
I was gonna talk about like the intercooler, like when that have to do like with like thermal energy.
Yeah, well, the intercooler is taking the hot exhaust gas, right?
Basically, yeah.
And then it's cooling it down so you don't overheat the turbo.
Yeah.
Burn the
that's
turbo
basically-
fans out.
That's basically what it's coming from. It's connected to the turbo and it's giving turbo more air. So then when the air comes out,
I thought the thing was just the cooler. Anyway, chemical energy is
Chemical energy.
that's when you mix two chemicals together and they make like a explode, not explode.
It can, okay? How many people have taken, their mom had, you got blood or something, you got blood on a white shirt,
Uh-huh.
and your mom gives you peroxide.
Yep.
And what happens to it?
Foam.
It foams up. Well, I did a weird experiment when I was working at a clinic one time. We had old blood from a blood bank that we had to destroy. So I took a pint of whole blood cells, okay, in a container, and I put it in a glass beaker, and I poured peroxide in. Now it foamed up and made a mess. But it got so hot because it oxidized. And that's a chemical reaction. It got off a lot of heat, and that's the way a lot of these chemical reactions work. What do we do in the wintertime? You walk outside, you slip on the ice, and you fall. So what do we spread on there?
So,
Salt.
sometimes that doesn't work though.
If it's really, really cold, it won't work. But is that a chemical reaction?
yeah.
Yep. We're taking this solid crystal, sodium chloride, and it hits the ice, and now it makes big fancy words called dissociation, and it breaks up into its two equal parts, sodium and chloride.
You can use house salt too.
Yeah, salt is salt. Whether if you look on the periodic table,
Cat litter, yeah. No, that's
Guys,
a rip.
when you look on the periodic table, the far left-hand side, okay, you got hydrogen, then we go down, we got lithium, and so sodium, lithium, potassium. Those are all far left side on the periodic table.
Oh,
Well,
okay.
sodium, Na, third one down. Okay, that's a poisonous metal. If you eat raw sodium, you're going to die.
Yeah.
Okay? First off, you're not even going to get a chance to eat it because it's going to react.
That would suck.
But we mix it with chlorine, which is another poisonous green gas, and it reacts. These two poisonous substances turn into a salt crystal. and we put it on our food.
They put that.
And you can eat it
And
without
we can eat it without dying.
That's for how long?
That's what salt is?
Salt, yep.
There's no way, there's no way.
It's true.
Isn't it CO2?
That's carbon dioxide.
Oh.
Yeah.
See, if you look at salt, we talk about salt as this. Sodium chloride. Now, here's the funny part. We talk about batteries and electricity.
It's nasty.
All right. Sodium is positive, chlorine is negative. These balance out. What happens to a magnet if you take a positive side to a negative side?
It doesn't stick.
No, positive and a negative side. They connect.
Yeah.
If you go positive to positive,
It does.
they kind of like
Yeah, like
push apart. They repel. So, look how easy these are to come together.
Yes.
All right, if we were in chemistry class, this would be called an ionic bond. All right, because it's positive and negative charge. Now we take this lump of salt and we put it in water, and then this sodium breaks up by itself, and the chlorine breaks up by itself. And that's how we make, and that's how our ice breaks. Our ice melts doing this. Next one, electrical energy. What's electrical energy?
It's
Makes the
basically
light
electric.
work.
Turns our lights on, makes our Walkmans go. Walkmans, don't tell them how old I am. You know, our iPods, okay, all of our MP3 players. What about lightning? Is that electrical?
Yeah.
Yeah.
What's happening in California right now? It's all over the news.
Lightning storm, something like that.
Well, the lightning started the forest fires. Southern California and my old home base at Camp Pendleton is burning right now.
The houses are on fire too, right?
They lost a couple
That big
houses.
fire.
Yep, they lost a lot of houses.
And something
Did
like that happened in Arizona too.
Arizona gets them all the time as well. That fire tornado was on the news a couple weeks ago.
Fire tornado?
Fire tornado, 5,000 feet tall
It was
of a tornado of fire.
tornado.
Oh,
What?
damn.
Because the heat gets that hot in those forest fires, it generates its own wind currents. So think of the dust devils, but in a forest fire, it grabs the fire and it just feeds it.
It keeps going.
All the
and
way
it
to the top.
stays like that. It just keeps going.
All right, electrochemical energy.
No.
But it's a flame from the
That's
dying.
So what are we talking about when we talk about electrochemical energy?
It's still a piece in there.
What do you think we're talking about here?
It's electric and chemical energy.
That's really
That's
nice.
low.
This can also, guys up here, this can also be part of our, not solar.
Solar system.
Okay, that's down here, electromagnetic, all right. But electrochemical can be some of our solar, because, like I said, we don't just hold up the plug to the sun and hope everything charges. Because you'll just be standing here until you can't stand any longer.
Yeah.
What do you have to do to charge something with the sun?
You would have to use the solar.
Leave it out in the sun.
You need
Those
solar,
solar poles, you know,
the solar poles, the solar
Oh,
panels.
them fans that go.
The pan.
Here, I want to,
That's different.
Whatever.
That's
You
a
use
windmill.
wind. You would use windmills. You can use that for
Yeah,
electric.
Yeah.
I'm trying to tell you.
so we have a solar panel, okay, and they have all these grids in them.
Yeah, there's different stuff in it though.
Yep,
Different
and
layers.
it looks like this, but inside, if I turn this flat, you got layers of stuff in here, okay? Similar to a battery, there are two substances that have positive and negative charges.
Did you?
But you could like see like the stuff that's in it, like sodium.
Oh, Tiffany.
It's fine.
So, Tiffany,
Huh?
pay
What?
attention.
Sorry.
So, when the solar panel is just a solar panel, how does the sun collect that energy and let us power our phones, charge our phones, heat our water?
I think what happens is when the sun hits the ray thing.
So the sun's coming down, and it hits here.
Mm-hmm.
So is it just trapping the sun's energy and just feeding it?
It basically
No.
absorbs the heat and it.
Well, it's not the heat. It's the light. The light ray. It's a real particle.
Yeah.
So it lands and hits this. All over the place. Millions and millions of them. Well, there's a chemical here inside the solar panel. The sun reacts and it heats up and it knocks off a charge. So you start to make all these negative electrons get moved to the bottom. So what's on top? If you have positive on the bottom, or the bottom is negative and the top is positive, what have you created? Josh.
I have a question about this.
All right, real.
Neutron.
What does this look real quick?
Giant battery.
It's like a battery. Except it's like a running battery in the sense, what do we connect to them? Every solar panel or solar charger that we have has what attached to it?
A wire.
Has a wire. And whether we plug it into our phones, okay, for the small little one, the solar panel calculators.
Yeah.
Or if it's a big one on the house, we run them into really big giant batteries somewhere in the house,
Like,
so we can,
they do it with like generators too?
yeah,
Put it
we
to
run,
generators?
we run that, and it could just run the generator.
Mhm.
So we don't have to give gas and diesel fuel.
What if there's a power outage? Would that go out too?
Yes, if we lose power, right, all the lights in the room go off, but we have solar panels on it. We're not gonna be able to run everything in the building,
But it still keeps the lights on.
but we might have emergency backup lights. We will be able to maybe run the water, okay, so we can use the toilets. We might have,
Stove.
I'm sorry?
A stove.
Stoves in here are gas, okay?
Yeah, I have.
Mine's electric.
No, some are
I don't know what
electric.
you're
There's a
talking
big
about.
field close
have
to
the
here
gas.
that has millions of them.
Yes, there's a whole boatload of these on Route 22. Okay, just past Moravian Academy.
You talking about by that church and everything?
Yep,
Oh,
they put a big, huge field in, full of them,
Never stand.
and it helps augment their electric bill.
Oh, by the soccer field?
Yep.
Wait,
So-
what's that to help run? That the church or the?
No, they may just use it for, if their bill, let's just say their bill is $1,000 a month, I'm just gonna throw a number out there,
The bills that go down.
alright? And say that they use $1,000 a month of energy for that church or the school, costs $500. Okay, let's just say it's $500 worth of electricity that they bought.
Mm-hmm.
And let's just say that that solar field makes $1,200 a month. Okay? Am I making more energy than I'm getting sent into me?
Yeah.
You're making more than they're giving you. So what you're doing now is you start feeding it back to the electric company, and they start buying it from you.
You become rich.
Well, you don't really become as rich as you think, but it lowers your bill.
They got a good amount of money.
Yeah. So, let's go to the next one. Electromagnetic energy. Part of the sun does that as well. What comes from the sun?
Heat waves.
Heat waves. What other type of waves?
Radio waves.
Radio waves come through. What else? Summertime. Heat.
UV.
Ultraviolet. Good. That's the ones that give us the sunburn, the suntan, or skin cancer. Okay. UV rays are damaging rays. Okay. What do you got, Josh?
Now the question about the solar panel. If because of all the chemicals inside of the solar panel, do you have to have somebody come and refill those chemicals? Or
No, they're sealed. It's a sealed event, so when the sun goes down,
Yeah.
this reaction goes both ways. Now, without getting into a big chemistry lesson, all right? Let's just say we have this reaction. I'm just going to put this reaction here: water plus more oxygen. I'll put this on this side here.
I'm sick.
Gives us H2O2. That makes hydrogen peroxide. Okay? Now, if we have the same amount in a container, with no more and no less, then we have this. This equation goes back and forth all day long. Okay?
What makes hydrogen peroxide bleach stains?
It oxidizes. It has extra oxygen. The oxygens pop off. And all the girls with makeup, remember this term? You see this on TV all the time, right? Free radicals.
No.
Yep.
Your makeups will have free radicals, and cleaning agents have free radicals. They're skin damaging. They clean. Oh, they clean. But they kill all the good stuff as well. And they damage good skin. So you don't want all these free radicals. Well, when this oxygen, who's nice and happy by himself, breaks up into two of these, he's not happy and he's not happy. So these two guys are looking to get happy. So they need to find two more oxygens to bond to. And it goes back to O2 and O2. He's happy. These are damaging and caustic. These will burn things. Okay? And react with stuff. This is why it bubbles. Your skin bubbles when you put it on a cut.
Yeah.
Because those oxygens are breaking apart and they're trying to bind with other things. And the byproduct is it gets hot. That's where you get that little burn from.
If I hurts.
Yep, you get that little burn. It's a little bit of heat that's generated. And what do we have in our skin?
But
Nerves. That's what makes them, you feel it. Okay? What you have, Isaiah?
I forgot.
Wait, so how come they can take out your nerves and your gums?
What's that?
How come they can take out your nerves and your gums?
What do you mean in your gums?
Like, when
You
I
need
got
root canal?
no, when I got, I don't know if that's what it's called. When I got my teeth pulled, one tooth didn't hurt, but the other one hurt.
The problem with the jaw and teeth, depending on where it is, they may kill one nerve, but if there's a nerve close by, okay, and it's really, really close, signals jump. So if they killed one nerve,
Is that what they do when you get a root canal?
yes. Let's just say that that's one nerve, and you also have this nerve
Don't they give you Novocaine?
that kind of hangs out, even though it's supposed to go that way. And if they kill part of this nerve, signals sometimes will jump.
So they
And that's
kill-
where you sometimes
they
get
kill your
pain.
nerves when you get root canals? Because they say like
In the
there's
tooth.
they say there's like 4 nerves right there.
They kill the nerve in the tooth. That's what they do.
I
Ew.
don't take.
All right. All right, how about sound energy, guys?
Like from someone's echo, they get a vibration.
Okay, so we got
Like
vibrations.
stuff that comes out of your headphones.
Yeah.
Speakers.
All right, so one at a time. We put our headphones in, and what do we hear?
Music.
It's not a guy on the other side yelling in your ear, is it?
Depending on what you listen to.
Okay.
Sometimes,
You really got a guy in your headphone yelling at you?
Screamo.
yeah, screamo, they be screaming.
There's a real person in there talking to you.
Inside the headphone.
In your headphone.
Do we have
Piece of
Bluetooth?
plastic, is there a person in it?
I have a
Yeah.
miniaturized version of you in my headphone.
No, there's a voice in it.
Okay, there's a voice. But it's not a real person, is it?
No.
Nope.
You hear different sound waves. Opera singers. Somebody has really high-pitched voice. Does it hurt your ears?
Oh my god, yes.
You could break glass.
And if you jump into probably Jose's car right now when he gets home, he's probably got the speakers thumping, so when you hear it, all you hear is this. Boom, boom, boom. And what does it feel like?
I hate the bass. I
I
really
love
do.
the bass.
What does the bass feel like? Hold on.
I feel like a heartbeat.
You feel the vibration in the car, and you feel like you're getting hit with wind.
Yeah.
Okay? That's moving air. These are sound waves. We have waves that look like this. We have waves that look like this. And we have waves that look like this.
You know there's on the breathing machine it goes like that?
Yep.
The
Now,
nebulizer.
if you look at these
No.
three different waves, guys,
The thing that goes like this.
that's your EKG. That's your heart.
That's not breathing.
If you look, guys, up here. If you look up
What are you
here,
talking about?
Huh?
between the waves.
That's like
Yeah,
a,
whenever it goes beep,
that was like a.
Tiffany.
dead, huh?
So you look at these sound waves. Is there a lot of stuff being moved between these?
Yeah.
Well, whenever they're bigger, there is movement, right?
Well, you've got a lot
It's
of.
just like a fast,
That's
it's like a
look
fast
like
beat. It's like a fast beat.
Whoa.
Right.
Dubstep.
Hey,
Down here?
It goes-
It's
Water.
like an even set beat. It's just like boom, and that's a slow beat.
The first one's like rock.
Here's your speakers.
Like,
Tweeters,
Tweeter.
mids,
And some.
and there's your subs.
Mid.
Now,
That's how I know how to talk about
now if you look here, guys,
never.
if you look up here, this in here, there's a lot of what here? Space.
Bass.
So it's louder.
So it's got to move a lot of air. Okay, this is why you can't take a Fiat and put like 15, 20 subs in there. 20-inch subs.
They have a sub right under the passenger seat.
Right, they have a
It's
small,
nice.
it's a small
pretty
sub,
nice.
it's good. Because
pretty
it's
nice.
designed to move a certain amount of air
Can't blow.
in that
Someone
space.
had
If you
a
get like a
stereo
bigger one,
speaker
you
in
get
their
a-
truck.
Alright guys, pull it together. The sub has to move air. If you can't move enough air, you could put a 100-inch sub in this room and brick the wall, brick this up, and brick the ceiling.
That'd be
And turn it on, and nothing's gonna happen. Because
Seriously?
you can't move enough air in a confined space.
Yeah.
Okay? Now, if
So if
I put the sub outside
Definitely.
and powered it up, I have what? I can move a lot of what?
air,
Air. And I have nothing on the other side to do what?
stop it.
To block it. So when you're designing stereos, that's what they have to really think about, is moving. This wave, this sound wave, has to move enough air so you can actually hear it. What do you got, Jose? I'll get your
Oh,
question
that's
next time.
it. Okay.
I don't.
Like when you have a speaker, that shit just like there's like air, but like it's a smaller type room. Doesn't it make it louder?
No, it's because they break down the speaker, all right? They know
What
that,
if like the acoustic in the room is just like it just like echoes. When you like say you listen to music in a room and you hear the bass going on,
Okay.
and like if you switch the speaker from like this room to like another room.
Oh, okay. That's just the acoustics in the room.
Yeah, that's what I'm trying to
Yeah,
say.
so-
Would it make it
You
loud?
go in the bathroom on your cell phone, you talk to somebody, it echoes, right?
Yeah.
Is there a lot of soft things in your bathroom, or is it all hard tile and glass for the most part?
Tile glass.
Tile and glass. Okay.
I only blast my music in there.
Now, if you're in the living room, you've got what?
Self
Right,
cushioning.
couches.
Carpet, couches.
Sound system.
So you've got stuff that can absorb. So we lose what?
Sound.
We can dampen some vibration. If I take
I got speakers all over my.
if I take this foam die, okay, it bounces, right? If I took it and I bounced it
Oh, Giannis.
into Yana's head,
Look at that puff.
what does it do? It just kind of absorbs. And that's what our sound does. That sound wave gets absorbed, and we don't get that vibratory sound in the room. All right, and the
So I
last
have
one.
a question for like the 6th year.
All right.
How come when you're in a car and then you open the doors? Like, is it literally did it get louder or am I bugging?
No, when you're outside, you open the car door up.
Yeah.
Okay, the speaker is out here on the door.
Oh.
So you open up the door and you're standing out there. You're like, you giving sound. You become a stadium now. Okay. Now if the speakers were say in the dashboard. Okay. And you open the door, it probably wouldn't sound a whole lot different.
It's louder when you open the door.
Yeah, right.
Wouldn't the turbo and the wall valve have something to do with the sound energy too?
Yeah, that revving and that release.
Yeah.
Well, it is. It's high pitched, isn't it?
Yeah, they're like, yeah, it kind of sounds like high pitch when you're in it, but then when you're outside of it, you can't really hear it that much. But when you're in it, you could like, it's basically like sound energy.
Well, also you remember the direction that you're going into.
Yeah.
All right. Any Big Bang Theory fans?
Yeah, me.
No.
Remember when Sheldon dressed up as a Doppler effect?
Yeah.
Right. Middle, you thought he was a zebra.
Yeah.
All right. Sound goes in one way. So if you're here, and the sound is moving toward you, we're going forward, right? So we're driving our car.
Yeah.
The engine's in front of you, right? Zzz, you're shifting, going through gears, all you hear. Zzz, zzz, zzz,
Yeah.
Right? You're driving into it. That's why you hear it.
Yeah.
If I'm up the street and I hear you coming, I might hear the car revving,
Yeah, but you can't hear.
but I don't hear it until it gets closer.
Yeah.
But as soon as the car passes me and it's going away, what happens to that sound?
Hey,
Faint.
It
Fades.
gets less and less and less. All right? Because sound doesn't just go this way and come back. It has to hit off something to come back at you. If it's got nothing to reflect it back, it just keeps on going
I
and
know,
going and
like, once
going.
when you like stop at the red light, you're like, yeah, that's definitely a full valve in that car. But then,
All right, the last one, guys. We'll finish up here. Nuclear energy. What happens there?
Yeah, I don't understand that because like, why is there a nuclear bomb? What is a nuclear bomb?
Like plutonium?
What is a nuclear bomb? Have you not seen Hiroshima?
No, but that doesn't tell me. It can tell me what it can do. It doesn't tell me what it is.
No, it's a valid
It's
question.
like an atom, like pulling an atom apart.
did you not see
Uranium?
Japan?
Plutonium.
They didn't drop the
Plutonium.
nuke. They dropped the atomic.
You know
All
how,
right, a
like,
nuke is an atomic
They
bomb.
dropped a nuclear bomb.
The nuclear bomb is an atomic bomb.
Huh?
They dropped it on two
All right, guys.
different cities though.
All right, Ryan. Uranium
Why?
is on the chart, isn't it?
Yeah,
Is plutonium on the chart? Yep.
it is.
Yep. These are what they use
In the F?
to make our nuclear weapons. Different types, okay? But what they do is they take the atom, and if you look at the periodic table,
It's
The
uranium
bottom part, right?
235, or is it 238 up there?
What's that?
Uranium.
See where it says F?
Uranium.
The
35.
maroon F
235? Yeah. So,
on your side?
this is a big molecule. This is a big atom, guys.
That's the S area though.
Guys, this is a lot, this is a pretty big atom as far as atoms go. It has a whole lot of electrons. That means it's got a whole lot of protons and neutrons inside the nucleus.
That's what I'm saying. And then they try to
So when we,
split it.
yep, we shoot a neutron, okay? We shoot a neutron into it and split it. And then all those neutrons get split and they go to the next set of atoms and they split and causes a chain reaction. Now it happens this fast. Matter of fact, this fast and it's been over for that fast, a while ago, okay? And it generates an enormous amount of energy. So if you watch some of these shows where you see a nuclear detonation, you see everything get blown out, and then a couple seconds later, it gets pulled back in, okay? So it generates so much energy going out this way, and then the heat that is generated. What happens when you look in the summertime, you're driving, what does it look like on the road?
Waves.
Little waves, right? Those thermal waves, those are called mirages. So heat rises. So imagine when we detonate a nuclear bomb, how much heat is detonated? We get a lot of heat that we have generated.
Wait, that's a mirage? That's what that's
The
called?
little squiggly line, that's a mirage.
Oh, wait, but I thought it was when you see a Coca-Cola machine and it doesn't.
No, you're watching it, that's a commercial.
Oh.
So, guys, tomorrow we'll start up on the individual spots of kinetic and potential energy. All right? And we'll go back into the future. But I want you guys to go online today, Google a nuclear explosion. And there's hundreds of them online. And watch a slow motion nuclear detonation.
Have you seen what it does?
And watch what goes on.
Have you seen the pictures of what it does to people?
Oh yeah, the vaporizes. Yep, vaporizes them.
You ever see the Hills Have Eyes?
Isaiah, do me a favor, collect all the bell ringers, would you please?
Yeah.
So, energy. What are we having ideas about what energy is? Wendy?
Like the amount of something that you have like the force of something.
Okay, so you put some words up here. We got force. What else? What we got?
Energy is like energy in your body, the energy that turns on the lights, turns them on and off.
Okay, what turns the lights on and off?
Electricity.
Electricity. What else?
Isn't there physical energy too?
Well, that's a form of physical energy, but how so? Clarify that.
We need energy so we can like walk, we need energy to eat, we need energy to sleep.
Okay.
I can.
Food.
You can't grade them?
Heat.
Heat is like energy because if you don't have heat, you will suffer.
Okay. So all these here are types. But actually, let's get to a definition of what is energy. Okay. What can we do with energy?
Jump.
Jump. Power things. What else?
Animals use energy sometimes to fly.
Okay. So movement.
Gas.
Okay. Gas is an energy.
Wait,
Okay.
isn't solar?
Solar is another type. But energy itself is the ability. This is where you'll start taking notes. It's on the slide. The ability to do work or cause change. Okay? So, the ability to do work or cause change.
Okay, I gotta get some paper.
Ken, am I doing work right now?
Yes.
Why?
Because you're moving, you're using your energy inside the body.
Yep, good. So I'm using the energy my body's producing.
The energy in your brain is telling your arm to move.
Yep, it's sending a signal and this is moving. And I'm going to erase this now, real quick. Am I using energy?
Wait,
Yes.
can I ask you a question?
Okay.
Like, does our brain think of what we want to do before we actually do it?
Does our brain think about one direction for what I do?
Like, if I had it's like here,
Okay.
and I didn't scratch and it just kept itching, but my brain tell my arm to move and scratch it.
Yes, that's your sensory system of your nervous system.
Oh.
What do you got, Wendy?
Isn't it even possible for both sides of your brain to work at the same time?
Nope. No, it all works together. All right. So, what are the different forms of energy? We talked about some. We talked about a bunch of different types. Solar, nuclear,
Gas.
electrical, petroleum, okay? Here we go. Has a bunch of different forms.
Are you coming to Marcus?
This is what you want to put down on the in your notes.
We have to write all that.
Make it as you know it to yourself. Write it as you understand it. Has many different forms, all of which measure the ability of an object to do work or change another object. So, in order for me to make that move, okay, that eraser move, and I want to use this eraser, what do I have to do?
Use energy.
Use force.
Okay? Now, they'll measure that force. Yep. Feet per second, pounds per square inch. How do we buy our light bulbs? How do we determine which light bulbs we use?
Watts.
Watts. Voltage, right, we have 110 volt, okay? Or the big power lines, those are megawatt lines, those are million watt lines, okay? So, we measure things differently, okay?
I have a quick question. You know how, say you put a wire, you can get electrocuted if it gets wet?
Okay?
How come the wires on the electric poles, when it rains,
That's a good question.
nothing happens?
Nothing happens. Because the electric lines that are outside, the big ones, they're uninsulated because they're grounded. Okay? So if I were to put you on there, okay, and you were to touch one of those, you would get electrocuted because you're grounded. Alright? When the linemen work on them, okay, they get grounded and they actually work on those big megawatt lines by hand. But they, not the transformer, I mean the big lines. They actually energize themselves, so they have the same amount of energy running through them as those lines. But they're not touching the ground. They're not grounded. So they don't get electrocuted. So they can do all their work that they need to, and then when they're done, they unenergize, and then they come down. Okay? That's also why birds can land on wire. Why doesn't a bird get electrocuted?
That's what I was wondering.
Because the bird is not touching what?
The ground.
Nope. The lines are grounded, but not the bird. So that's why the bird can land on it, hang out here all day, fly off there. All this up.
Write that down.
Okay, yeah. So, in other words, there are different ways that an object can possess energy. Does a Big Mac contain energy?
A what?
A
No.
Big Mac.
Well,
Yes.
it contains energy needed for the human body, and then the rest of us we the rest of the Big Mac that our body doesn't need it creates fecal matter or something like that.
Okay. So, in a long sense of it, we eat the Big Mac, we break it down physically, right? We have to chew it.
Yep.
Yeah.
And then our stomach breaks it down with stomach acids, that's chemical. And then we absorb all the bits and pieces that we need.
Can I ask you a question?
Hold on, so we get all our stuff, what we need, what we don't need, alright, we get rid of as waste, and we store other stuff for later use, right?
Yeah. Wait, don't
No,
turn
not
it
doing
yet.
it. So, Mr. Wilson,
Okay.
my foster mom, my foster dad was telling me the other day, because we were talking about food and how quick I eat my food and how Mary gets in 30 minutes for me, she's still eating.
Okay.
She said it's not good for me to eat my food as fast as I do. And she said sometimes I eat it so quick, she thinks I'm not swallowing my food, I'm not chewing it. What's the big deal if I eat my food so fast?
Well, one is you probably won't always feel good. And two, you
I
can
don't
risk
chew it.
choking if you're not chewing it well enough. And then the third part is when it gets into your system, it's harder to break down.
Oh,
So if you're not chewing it as well and breaking it down enough, the stomach has to do more work.
10 chews per bite.
fast?
It can.
she can choose
Wait.
something, but
Go.
What? What causes? I don't know if this has to do with anything, but what causes lactose like intolerant?
That's actually an allergy.
Really?
Yep, it's an allergy. Our body doesn't, or whoever is intolerant to it, can't handle the milk sugar, lactose.
Yeah.
Okay? So anything that ends in OSE is a sugar. Glucose, sucrose, fructose, all that stuff. So lactose, that person can't handle it.
Yeah.
So their body really fights them back pretty bad. Alright? Who watches The Big Bang Theory? I've been using this example all the time. Leonard can't eat anything with dairy products because he's lactose intolerant. And they're always making fun of him. They're like, oh, if you have a lick of that ice cream cone, you're gonna stink up the house for a week. Okay? But it is. You can't digest it, so your digestive system has to do something with it. Alright? So it's trying to get rid of it really quick, or hold on to it for a while, or you get sick and you vomit.
Mr. Wilson, isn't it a disease like to get attached to something?
To get attached to something. What do you mean?
Like I was watching the show last night. It's called Two Broke Girls, and the one girl threw away the other girl's like pillowcase, and she had it since she's like been a little kid, and it helps her sleep.
Oh, it's kind of like somebody's binky blanket and all the other stuff. People get attached to objects, they don't want to get through it. Anybody here have a favorite shirt?
Nah.
Might have 100 holes in it, stretched out, but it's your favorite shirt.
I had a fear of like, but they
Okay.
gave it to me when I was at the hospital. And
So that's
and
what
it's-
happens.
And it's all ripped, but I still have it.
Are we ready to change it?
No,
Yeah.
shut off it. So I don't
Can
use
we
it.
turn off the front light? Because it's a little hard for me to see.
No.
Mr. I have a quick question.
Go ahead.
You know how you say when babies are in the womb, they can hear what their mother talks to them?
Yeah, we talked about this yesterday.
Yeah, I don't understand.
We went in here yesterday.
If they're not fully developed in the stomach, how do they hear?
They may just hear the sounds just become, as they develop, those sounds they become accustomed to.
Oh.
In like anywhere in like time or anything, has a baby ever started like talking as soon as they like got out? Or
I don't think so.
What like makes us talk?
We have to develop, we have to learn how to speak. Do you ever see somebody who is deaf or hard of hearing?
Yeah, why do they
My
talk?
aunt
They don't understand. They haven't heard, we're not making fun of, they haven't heard what I'm going to the beach today. They don't hear. If they have some hearing, they can usually talk a little bit. But if they have zero hearing,
Yeah.
they can't speak because they have not heard what the sound sounds like.
My
No.
brother's best friend who grew up with him as a baby, he was across the street from my mom. He's deaf and he can't talk. The way he talks, and one
Because
time,
he doesn't hear the
yeah,
sounds.
one time we were driving home from the park. And he put his head out the window, and my mom rolled up the windows, and his head was there. And no one knew what he was saying. We turned around, I turned around to see like this. Mom, look, Santa's the window. She, oh shit! She turned
Open
the
the
window.
All
And
right,
nobody
get back,
understood what he was saying.
get back on track. What do you got?
There's a bunch of our deaf people. I have neighbors out of the apartment building, so it's like my neighbors, they don't consider me deaf.
Okay.
And they're like, "Boo, can't talk," and like, they're actually nice people because they actually give us stuff every day.
Oh, it doesn't mean that they're bad people. It just means that they were never able to hear the sounds that we're trying to teach them or they're trying to say to you.
Yeah, we do all the sign language.
Yeah, they sign.
Yeah.
Because if I said, how can I make you understand that the letters PH in telephone makes it sound like an F? All right, I can't make that sound if you can't hear it. Okay? So you can't say it back. Avery, what do we have?
How? That always confused me. How did Helen Keller write all those poems if she couldn't see or hear?
Helen Keller is a very interesting case. She had a lot of people with her, and she was just dedicated to teaching herself how to do something. It's a classic example of if there's a will, there's a way.
Yeah.
Okay, to go through it. All right, is this back off? No more deaf, no more hearing impaired, nothing. This is energy, and you're draining mind. See, I wish we had these questions for anatomy.
Okay, this has something to do with energy. I went on a 9-hour walk yesterday, Sunday, and you know where Price Chopper is? The new Price Chopper in East Stroudsburg.
All right.
Oh.
I live in Marshall's Creek.
So you took a long walk.
I took a long walk.
Yeah.
Why does I have no energy and I feel really sick now?
Because you're tired. You use a lot of energy to do that. You probably didn't eat a whole lot either.
I don't eat
That's probably why. If you're not feeding the machine, if you're not stoking the furnace isn't going to make a lot of heat. So what we do is you'll draw it from your body. You'll take it from fat and muscle, and you'll draw that. Well, when that happens, you got nothing. All right, so back here for different forms. Is it about this?
Yeah, it's what is it?
Talking right at the same time.
When you put a fireplace, like a regular fireplace, because you said gas, and you have a wood fireplace.
Okay.
If you put if you put wood in the stove, those old stoves you put wood in the stoves, is that energy?
Yes.
What kind of energy is that?
That creates thermal energy. Okay, you put something on fire to make a hamburger, you throw charcoal on the grill, you put lighter fluid on it, you light it up, and you put your hamburger on the grill, right?
Yeah.
And it's good. Slice of cheese, a little onion, a little ketchup, and it's a good time.
Yeah.
Thermal energy cooks it. Heat energy.
Oh.
If anybody was here a bunch of years ago, Mr. Ferraro did a experiment with cooking a hot dog outside with solar energy, making a reflector.
He did that during the summer program.
Yep, did he?
I was here before the
Yep. So they take the hot dog, they put it in there.
summer program.
Mr. Ferrero, isn't it?
No, he just moved to a different place, that's all.
Oh, the one downstairs? I'm talking about the art teacher.
Oh, that was Mr. Squillis.
Yeah.
Okay. But yeah, Mr. Ferraro would take a hot dog, you make this device, and you put it out in the sun, and the reflected rays, the sun's rays, would cook the hot dog. Okay?
Wait, don't.
Not yet.
So, we have kinetic energy. We talked about that before. That is energy that moves. Okay? Kinetic energy is energy in motion, where potential energy is what?
Energy not in motion?
Okay, energy not in motion, so what is it waiting to do?
Go in motion.
To be used. Do we charge our batteries in our phones every night?
Yes.
Okay. So if we have a battery, right? Let's say one battery. Is it doing anything right now if this is in my hand?
No.
Just hanging out here, right?
Well, it kind of is.
If I'm holding it, it's not charging anything, is it?
No.
So it's not being used?
No.
We're not taking anything from it?
No.
It's just here.
Sometimes we are.
So if we have the battery here, it's not in use, are we storing that energy for a later date?
Yes, we are.
Yep, so we take it, we plug it in, and we use it. So potential energy is stored energy. If I take a rubber band, and there's an example coming up later. If I take a rubber band and I stretch it out, and I hold it out here fully stretched out, am I storing energy?
No, you're using energy.
No, I'm not pulling it. I mean, it's stretched out. I have it stretched.
No.
It's stored, right?
Yeah.
It's waiting for me to do what?
Use it.
Snap it.
Let it go and it snaps back? Or if I pull it back with one way and I let it go, what happens?
It
It
snaps.
It
flies.
flies across the room. So I've stored the energy in the rubber band by stretching it out. And I release that energy by letting it go. So that's potential energy. As soon as I let it go, what does it become?
Energy.
Kinetic energy is movement. Okay? Then we talked about heat or thermal. And then we have chemical energy. What is chemical energy?
Energy from chemicals.
But what does it do? How does it? If I take a block of ice and I pour a whole bunch of salt on it, what's going to happen to the ice?
It's gonna melt.
It's going to melt. Why is it going to melt? Does it get hot?
No.
The chemicals in salt will melt it.
Thank you.
It melts out because that chemical reaction takes place. All right, the salt crystal is just two elements, sodium and chlorine. All right, and a small side note, those are two highly deadly metals and a gas that we mix together and it turns into salt and we eat it. But you can't eat sodium by itself and you can't eat chlorine by itself because they both kill you. But when you mix them together, they have a chemical reaction and we make salt. And then we take salt and we put it in water and it breaks up into sodium and chlorine again in the water. Well, we can get energy from that, all right, and the breaking of those bonds, okay? Technically, chemical energy is the release of energy by breaking those bonds.
Mr. Wilson,
What do we got?
which one is the energy like when us, like we get energy like for hyper and stuff? What kind of energy is that?
Well, energy is energy. There's different forms, okay? There's a lot of different energy in your body. You have electrical energy in your body,
Oh.
okay? You have kinetic energy moving, right? Moving, we're doing stuff. Your heart's always beating, okay? You have fat in your body. So
Fat's a
fat stores energy, okay? So we can use it later. Because Tiffany is this big, I'm sorry, Teresa is this big, all right? And she went on a 9-mile walk, and she didn't have a big dinner, probably didn't have a big breakfast. She feels all drained. Her body was saying, well, she didn't give me any energy to go on this 9-mile walk, so I'm going to take it. I'm going to take a little bit from here, a little bit from here, a little bit from here. And that's what allowed her to make that 9-mile walk.
Like I was gone for like 9 hours.
And today you feel like you were being, you're like, I can't move, I feel like garbage. Okay, what we got?
When I do like a back handspring, what kind of energy is that?
Are you moving?
Yeah.
Kinetic energy. Yep. All right, electrical energy. Winter time, everybody got big heavy socks on, gonna go run through the house.
Yeah.
I'm gonna go like this. Snap. Now what happens?
You get a little shock.
You get shocked.
I do that on my trampoline also.
And then people do, they go to their pet and they're mean to their pet and they're like, come here little kitty, come here little kitty.
That's so wrong.
And they're like, and they run away from you, right?
That's so wrong.
And then they wonder why in the middle of the night they come up to you and they're like, and you wait, why do you have face scratched up?
My
Shock
cat.
my cat. And you're like, I get you. I know you sleep at night. It's when I'm up. I got you. What you got?
Yeah, I stroked my cat a while ago and it woke up, came up to me and just sat down on my chest and went like this.
Yep. Cats do crazy things. So,
That's why I have a dog.
we generate that static electricity, okay? So, I have to discharge it. That's that shock that you feel. All right? How about somebody takes, now I can't do it anymore, right?
Right, 'cause you're
'Cause I
bald.
got nothing on my head to take the balloon and my head looks like a balloon right now, all right? So you take the balloon, rub it against your hair, and what happens to it? Does it stick against the wall?
Yeah.
What else?
Your hair.
Sometimes your hair will stand up, you put it to your hair and it goes like, not in my case, okay? So, what about at night, in the summertime, thunderstorms, and what?
Lightning.
Lightning. Is lightning electricity? Lots of electricity. What we got, Avery?
How come when you touch a tree while it's lightning in, you get shot?
You don't want to touch a tree when it gets hit by
I
lightning.
have a screen. I was living with this old lady. She didn't die, but she was a tree and I wish she could. And she survived it though.
Oh, you can survive.
Mr.
Electricity?
Wilson, you have a balloon?
No.
You made me take my hair out for
You
nothing.
look like the Bride of Frankenstein right now. Okay? All right. So, electrochemical energy now. What goes on here? Guys, we talked about electrical energy. What happens with chemical energy?
Isn't that like, it's like electricity, but it's the opposite.
This one can get in really, really a lot of detail. But we can generate electricity with certain chemicals.
Oh wait, were we supposed to write those down?
Yeah.
Oh,
Okay. We can generate electricity
Right now, what you're writing now?
with chemicals. Then we have electromagnetic energy.
like
The UV rays from the sun, the gamma rays from space.
Solar power.
Part of solar power, the rays that we collect, those photons that we collect, infrared, ultraviolet, UV, all those things we talked about. How about sound energy?
Like headphones.
So we put our headphones on, okay? We got our Dr. Dre, $2 million headphones, okay?
200.
That made him a billionaire recently. And is Dr. Dre in your ear singing to you? No. He's right now on vacation with his billions of dollars. But you hear what in the headphones?
music.
You hear the music. You hear different sounds. You hear the bass. You hear the really high tweet sounds.
Yeah.
So we have different sound waves. Okay.
Yeah.
That's why you can sit here and people sound like this. Or people sound like this. Or people sound like different sounds, right?
Yeah.
Different sound waves. If you're standing in front of a bass speaker,
Mister, you know how like helium, you suck it in your building, but is that sound wave?
it's the same. It's a sound wave, but the helium affects how that density of gas is not as dense as oxygen. So when it goes across your vocal cords, it makes you sound like this for a little bit of time. So we get back to enough oxygen in our system to breathe out. It's a denser gas. So that's why we don't sound as high pitched. With helium,
Can it kill you?
it can kill you if that's all you breathe, because we need what to survive? We need oxygen.
Mister, I was
We need a certain amount of oxygen.
Mister, I was watching like a while ago, because I was going to die, and these two people went in like a big helium
No, my nose
thing,
is
like it was like
All the
it
balloons?
was like a float, and they went, it really ended up a float, They didn't suck it in, they went inside the float.
Oh, they went inside the float.
Yeah, and it had helium. And
That's
they
my
died
point.
because they couldn't find the exit.
There's no oxygen in there. It's helium. Helium itself isn't going to kill you. It's the lack of oxygen that's going to kill you.
Can I get a tissue, please? I'm
Yes.
sorry.
That's what happens. All right. So sound energy. When you guys are in front of a big speaker, what do you feel?
Nervous.
When you stand in a big speaker, do you feel?
Shaking.
The
You feel it?
vibration.
Boom, 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 boom. All right. All the vibrations.
Just listen.
Yep. The beats. Those are sound waves.
I heard that's how deaf people hear the music because of the waves.
They can feel. They can feel the beat.
Yeah.
It is so loud because at my aunt's birthday party, because she's deaf and she can't like hear anything.
So she needs to feel it.
We had to like put our stereo system next to like her, so she could.
So she can listen to it. Now, the last one
Nuclear.
is nuclear. What do you think of when we talk about nuclear energy?
Chemicals.
Bomb. What else?
I think of like CAT scans and MRIs and stuff like
Okay. There is not those particular tests, but there is a department called nuclear medicine, and what they do is they're not taking an X-ray of you with this type of nuclear stuff. They're injecting you with certain radioactive chemicals, and they're safe. All right, they're very low-level radiations, but they can track them in your system and find out what you have. What you got, Wendy?
Did you ever see the iCarly episode? The episode where
this-
yes, it is.
Then get to the point.
Carly had to make a nuclear science test, and she made it was like one of these where I think it was the right episode where she puts her foot in cow milk or goat milk, and she touches a.
Oh, it's the nerd
Yeah.
and cow milk and whatever thing.
Yeah.
And I tuck in their tongue in a little
Yeah.
plastic tube.
That was
thing.
her project. It was weird, but I always wondered like how she did that.
Oh yeah.
Magnet.
I have no
Magnetism.
Basically,
Alright.
All right, guys, enough of that.
Like a tube, and they put the two tongues on the inside when they were one was in
Wait,
vinegar,
magnetism,
one was
right?
in
Yeah.
goat milk, and it just lit up the tube.
Yeah, all it is just like a potato clock. All we're doing is taking the energy from something else and collecting those electrons.
Right?
Reality.
Like, you know sometimes how like they have to like inject you with the stuff so they can light up.
Right, that's
like,
the nuclear medicine studies.
Somebody has to explain that.
I just did. They inject those, I did, they inject those dyes into you. And they go into the areas they want to study, and then they do a scan, and then they'll see that area light up more.
Oh.
That's where it comes from.
Now I
Mister.
got it.
Could people get energy using heroin or no?
Oh yeah. Maybe.
No, there's no energy value.
Makes you tired.
No, that has side effects that affect what your body
even go
does
there.
I use heroin.
with how your body functions and things.
I don't.
James Aquarius has got his machine. Alright, potential energy. Yes.
Wendy.
You
Wendy,
shooting the camera?
what's that?
You shooting the camera? Oh, yeah.
Yes. So, potential energy. What does potential mean?
The possibility.
Possible. Alright? So if I have a battery, it's possible that I can power my phone, right?
Yes.
Or if I have a battery, it's possible that I could put it into a flashlight and have it do what?
Light up.
Light up.
Light up, turn on,
Yep. So potential energy, without
Mr.
writing
Wilson.
all this, alright? Potential energy is energy stored. Potential energy is also called gravitational potential energy. Don't worry about that part.
Mr. Wilson.
What do you got?
It's about the charging stuff. For example, I have an iPod that charges. That doesn't take battery.
Right?
What is it in
There's
the
an
wires for it to charge?
There's an internal battery.
Oh.
Yep. So potential energy is energy that we can use at a later date. It's stored. Teresa, if you had gone on your 9-mile hike
Hour.
after you had, or before rather, having a really big meal, okay? You had a really big breakfast, you had a really big lunch, when you got home from school, you had a snack, and then you went on your little hike, would you have felt better?
Yes.
Yes, because all day yesterday I didn't eat.
Okay. Would you have had more energy?
Well, yes,
How come, Sharon?
because you have, food and then you like walk through it and have it.
Right, because you fueled your machine, your body is a machine, okay? You fueled it up before you went out.
I got stuff like this.
So you took all this food, potential energy,
It's like carbs, so you gotta
Carbohydrates.
fill up the gas tank before you go out.
yeah, that's a great point. Before you go on a long trip, in the car, what do you have to do?
Fill up your gas tank.
Fill the gas tank up, we're not going far. Is gasoline potential energy or kinetic energy?
Potential.
Potential energy. Is it moving?
No.
Gasoline doesn't move, just sitting in the gas tank. Just sloshing around in your gas tank waiting for you to go. All
Wait,
right?
then how does it release out of the gas tank?
When it gets pulled from the gas tank to the engine, and it gets mixed with oxygen, and
So it is moving.
and we catch it on fire, and then we break down. This is where a lot of the energy doesn't change per se. Okay, we don't make new energy. We took the gasoline. Okay, we're gonna use your gasoline. Okay, your potential energy. You're now gasoline and oxygen mixed together. You're the combustion chamber, so we pour it in there, and you're the spark plug. So you catch it on fire. So the gasoline burns. Okay? We get hot gases and moves the piston in the car. So we took potential energy, and now we turned it into what? When the piston moves, kinetic energy.
I have a question.
Hold on, I want to catch with this. So we take potential energy, turn it into kinetic energy, and what happens to that piston in the car while you're driving?
It
goes up
It goes up and down. Now, I want everybody really quick.
There's actually a row of pistons.
There's a whole bunch of them, whether you have a 4-cylinder, 6-cylinder, an 8-cylinder. Now, everybody take your hands, put them
They
together.
actually have 10 cylinders.
10 and 12 cylinders too. Now, rub them together really fast. Really fast. Now put them on your face. On your face. What do you feel?
Warm.
Okay, so
I don't feel anything. That's what I'm doing.
do my hands.
She's cold blooded, mister.
Yeah, that's probably why.
Okay, now,
She doesn't have,
what did we just do? I had breakfast this morning, right?
Yep.
So I took some energy, I stored it, I'm using it now. So I made my muscles move, and what happened? What did I generate?
Heat.
I generated heat. So I took scrambled eggs and bacon, and I turned it into heat. Energy didn't get destroyed, it changed. I ate it, it was potential energy then, I ate it. It went into my system, I used a little bit of it, I stored some of it,
Okay, this.
I used it again, and we have byproducts.
I have a question though.
Hold on, Winnie has one real quick.
I have 2 questions.
Make it quick, one question.
One?
One.
Alright. You know how, do you ever see the Todd family where that guy, he rubs his ankles together, he can make fire? Is that true? If you're really ashy, you can make fire with your ankles?
I have no idea. Sharon.
It's like, you know when it's like really hot outside
Okay.
and you're out in the sun and you get tired? Does the sun take away your energy or something?
No, what the sun does is the sun causes you
To lose.
to,
To get really sweaty.
well, yeah, you do. You get sweaty, you get hot. All right. So if you're just sitting in the sun roasting like a baked potato, okay,
Or a lobster.
we get hot, we start to sweat,
Yeah.
we start to lose energy because our body wants to have what in its system?
Water.
Water. Okay. Now, when we get really, really hot, our body has to do stuff to try to do what?
I don't drink soda no more.
To cool it down. So that's why we sweat. Okay? Well, in the process of sweating to cool off, we lose that fluid. Okay? And then we get dehydrated. And when we're dehydrated, how do we feel?
Groggy.
Feel tired, maybe dizzy.
No, because I was at
Sleepy.
camp one time, I was
Sleepy.
dehydrated and I passed out.
Yep, you get cramps sometimes. So that's what happens. It affects you. It doesn't just say the sun beats down on you, it's like a death ray and makes you tired. No. There's a process. It affects what your body's doing and how it
What
works.
if you keep moving? Like, what if you're just running in the sun, like not just sitting there?
Well, now it's even worse. Because the sun's heating you up just by itself, and now you're running. So this is what your whole body is doing now. It's getting hot. So it just makes it go even
It's like
faster.
I'm jogging in the sun.
Yep. Well, you can. Yep. So you got to do it in moderation when you have the right capabilities. All right. Last one for the day. Give me some examples. Give me one example of potential energy. Hold on. Give me an example of potential energy.
Men.
What we got? Potential energy.
Men.
Oh, heat.
Wait.
Potential.
Heat.
Food.
Oh, I think that one. Never mind.
You said it earlier. Gasoline.
Oh, that's what I said.
Hold on, Shannon, give me another one.
The food in your stomach. Beer, right?
Well, we already got food, but what about that food that we didn't use in our body? Where does it get stored?
Refrigerator.
No, in our body. We don't put you in the refrigerator because we're not done with you.
I
got one done.
So like the stomach.
Outside the stomach. Fat.
Battery.
Battery. What else?
Could people be it?
What's that?
Could people
Water.
be potential?
Yes, absolutely. I was waiting for someone.
say water.
Men.
I was waiting for someone to say that.
Men.
Men? You too?
Women.
Okay? Yep, you're all potential energy. Why? Because I don't want to cut my grass. So I'm going to have all you come to my house and cut my grass.
No.
You are stored up energy. Potential, you can cut my grass pretty
You're
quick.
just old and
do it.
lazy.
Alright? But I don't have to do it.
Do it.
Okay? So yes, people can be potential energy. Okay?
I'll pay you grass. I'll pay you grass.
Like,
Yep.
A matrix.
like,
Oh yeah.
What's up with these two wearing headphones?
Miss.